In this video, we're going to talk about using logical indexing and masking in order to do some cool color manipulations with images. So what does masking look like in terms of finding colors in an image? So we talked about how an image is a three-layered array, and we also talked about the different combinations of values either on the red, green, and blue layer that produce certain colors. So when you're creating a mask in order to find a certain color, you're essentially trying to find a place such that the red layer is a certain value, the green layer is a certain value, and the blue layer is a certain value. And so for instance, let's say I had the Belgian flag, right? So let me draw this over here. So, okay, so the Belgian flag. So the left part is black. The middle part is yellow. Okay, sure, beautiful. And the right side is red. Okay, so I have this. Oh, bad. I colored outside the lines. Okay, just pretend you don't see that. Okay, so I have this Belgian flag where the left third is black, the middle third is yellow, and the right third is red. And let's say I wanted to figure out, or I wanted to create a mask that found out where all of my pure black pixels are. In order to do that, so pure black, if we remember, that's when the red layer is 0, the green layer is 0, and the blue layer is 0. So all three layers are 0. In order to make this mask, it's essentially going to be us doing some sort of logical operations with individual layers. And so if we were to write this out, the first thing that we have to do a lot of the times is separate our image into our three different layers. So let's just say we had R is our image, all the rows, all the columns first. Our green is our image, all the rows, all the columns second. And our blue is all the rows, all the columns third. So if I wanted to create a mask such that I was finding all the black pixels, so let's call it black mask, right? Black is when our red values are 0. So we're going to say where R is equal to 0, and where our green values are 0, equal 0, and where our blue values are equal to 0, right? So if you remember, so R, G, and B, in this case here, R, G, and B, these are just one-layered masks. They have multiple rows and multiple columns, but they only have, not masks, R, G, and B are one-layered arrays. They have multiple rows, multiple columns, but only one layer. So what we're doing here is we just have an array that we're checking to see where is it 0. Okay, and we also have a place here checking to see where it's 0, and here where it's 0. And when we AND all these together, that's essentially finding where our black pixels are. So if we were to draw out what our mask would look like, so it would be the same dimensions of our flag. This first third, everything in here would be all trues. Okay, then the middle third, everything would be all falses, and in the right third, everything would be all falses as well. Okay, those aren't even, but that's fine. Right, so in this case here, it's only true where the red, green, and the blue are all 0, because that constitutes a black pixel. So let's say we wanted to find out where our yellow pixels are. Okay, so yellow mask. Yellow mask. So yellow, if you remember, that's when our red and our green are 255. So very similarly, we would say our red is equal to 255. Our green is equal to 255, and our blue is equal to 0. Okay, and so this will be true at all the places where our yellow pixels are. So through separating our image into multiple layers and then using logical operators, we can create these masks that find out in our image where specific colors are. And then we'll talk about in future examples how we can use these masks in order to do cool things. So now that we're dealing with multi-layered arrays, which are images, this presents the concept of having multi-layered masks as well, right? So if we were to draw this out, let me see how my drawing skills are. So let's say, so I have Oh gosh, the perspective's off. That's fine. So red, green. Okay. All right. Things are going well. Blue. Okay, that's not too bad, right? So I have these three layers stacked on top of each other, right? If, for instance, I had a mask, which I'll denote by like some white, like a white square. If I had a mask that was just one layer, right, and I tried to apply this to my entire image, right, it's not going to affect the whole thing. It has three layers, right? So therefore, this one layered mask is not going to affect three layers, okay? Sometimes we want that, which we'll see in the examples how that can be beneficial. But sometimes we might want to have a way of changing our entire image all at once. And so we do that by creating a three-layered mask, which I like to call a super mask. And so it's the same mask, it's the same array, but it's stacked on top of each other 3 times. So therefore it would look like this, right? Where now we have a 3-dimensional mask or a 3-layered mask, and therefore we can apply that to our 3-dimensional array, and essentially each layer will affect each corresponding layer. Right, so now we're not just dealing with single-layered masks, we now can have multi-layered masks. And so how do you do this? How do you do this? So we already talked about how to create a 1-dimensional mask, right? In order to create a 3-dimensional mask, so we know how to concatenate horizontally, right? You kind of just do that with square brackets and commas. And we also know how to concatenate vertically, right? So that's using square brackets and semicolons. But then how do you concatenate in like the 3rd dimension? How do you stack things on top of each other? So there's no quick notation to do that. Instead, you're going to have to use a function. So let's say that I already had a mask created that was a 1-dimensional mask. Let's say it was finding all of my black pixels, right? So really quickly, so let's say I had R is image, first layer, G is my image, second layer, B is my image, third layer. And then let's say I had this mask that was finding my black pixels, so that's where R is equal to 0, and where G is equal to 0, and where B is equal to 0. Okay, so right now that's one layer. That is a 1-layer mask. If I wanted to create a super mask, which I like to call smask for a super mask, right? There's a function called cat, so I'll call it smask. And so the cat function, the first input is you tell it which dimension do you want to concatenate across, right? So in this case here, we want to concatenate across the 3rd dimension. So therefore, the first input is a 3. Okay, it's always the dimension. And then you give it what you want to concatenate along that dimension. So if we want to create a mask that it's just copies of itself stacked on top of each other, we can go ahead and say the first layer I want to be mask. The second layer I want to be mask. Oh, I ran out of room, that's fine. But also the 3rd layer I want to be mask. Okay, so now I have this super mask that I can use in order to affect an entire image. And this will make more sense when we do examples. But this whole cat function here, the cat function allows you to stack things on top of each other in the 3rd dimension. All right, so in this problem, what we're trying to do here is I have a picture of the Belgian flag, and I want to change it to the French flag by changing some colors. So if I were to run this just to see what image I'm dealing with, right? So I have this picture, this picture of the Belgian flag, and I want to change it to the French flag, where the French flag has, instead of black, it's actually blue, and instead of yellow, it's white. Okay, so in order to do this, we're going to have to create some masks in order to find our black pixels and our yellow pixels. And so before we create that mask, let's go ahead and separate our image into layers. So we have red is our image, all the rows, all the columns, first layer. Green is our image, all the rows, all the columns, second layer. B is our image, all the rows, all the columns, third layer, right? So in this case here, we now have all of our color layers, and each one of these is just one layer. And so now we can create masks from these layers. So in order to find our black pixels, so let's say our black mask, pure black is when red is 0, and when green is 0, and when blue is 0, okay? And then our yellow pixels will be where our, so let's call this yellow mask. This will be where our red is 255, and our green is 255, and our blue is 0. Awesome. So now we have the correct masks, right? The first one is finding where our black pixels are, and the second one is finding where our yellow pixels are. And so now these are one-dimensional, not one-dimensional, these are one-layered masks. So therefore, if we have a one-layer mask and we're going to change our image, we're going to have to change it layer by layer. So therefore, in order to change black to blue, right, it's to change it to a pure blue color, our red layer, where the black pixels are, we want to change those to be 0, right? Because pure blue is when red is 0, green is 0, and where blue is 0, and where blue is 255. Okay, so therefore our green layer where our mask is, black mask, is 0, and our blue layer where our black pixels were, we're going to change to 255. Notice here, by the way, these 3 lines of code, some of them are not necessary. If I already have a black pixel, then that means the red and the green at those locations are already 0. The only thing that's different is that the blue pixels, or the blue layer, has values that are 0. So technically, I don't need these 2 lines, okay, because they are already 0. So I could have just only had this last one, but we'll do all of them just for learning sakes. All right, so next one, changing yellow to white. So same type of thing. So red, our yellow mask, right? So red, white is when everything is 255, red, green, and blue. So therefore, our green at our yellow mask needs to be changed to 255, and our blue at our yellow mask needs to be changed to 255 as well. And so once again, right, these 2 lines are not necessary because if it's a yellow pixel, the red and green are already 255, so all I would have to do is change the blue to 255, but we are going to keep them there. So then now at this point, I have an image, or not necessarily I have an image, I have 3 separate layers. I have a red, a green, and a blue where I've changed some values. In order to make it into an image, I need to go ahead and stack these on top of each other. And so you do that with the cat function. So let's say new image will be cat, and we want to concatenate in the 3rd dimension. And so we're going to list out all of the things that we want to concatenate. In this case, we want to first have red, then we want to have green, then we want to have blue. Beautiful. Yeah, and so now if I wanted to show this, so I am show new image. Let's see. Oh, let me close this one. Let's see if our function works perfectly as intended. Perfect code, perfect code. Oh! So if you look at this, right, notice some of the black was changed to blue, but none of the yellow was changed to white. That's weird, right? So why could that be? So if we come up here and we go to this tool here, it's called the data cursor, right? If we click that, what we can do is on our picture, we can select a certain point and we can see some values. So let's look at this black pixel here, right? This black pixel should have been changed to blue, but it wasn't. And if I click on it, notice here, it says that the R value is 1, the G value is 1, and the blue value is 1. So in this image that we had, those black pixels weren't actually pure black. Like we were trying to find where R, G, and B are equal to 0, but in some of these pixels, it's not actually pure black. Interesting. So therefore, we're going to have to create a mask that accounts for that, such that there's some sort of threshold. And if we look at the yellow, right, so our yellow, we said that the red had to be 255, the green had to be 255, and the blue had to be 0. If we look at any point here, notice the red is 255, but the green and blue are not exactly the values that they need to be. right? So therefore, we're going to have to create some sort of thresholds on our mask to capture more of these colors because they are not pure colors. And usually that happens when you're saving an image. If you're saving an image, sometimes it has to compress some information and some of the values are changed such that they aren't pure colors. So let's go in and change our mask some. So let's say our black mask, if we're trying to find our black pixels, we're not trying to find pure black. We're just trying to find something that's really close to black. And so let's say pixels that satisfy that are such if the red, green, and blue values are all below 50. So we can do less than 50, less than 50, and less than 50. So once again, we're not searching for pure black anymore. Pure black will also be found because if it's 0, 0, 0, that satisfies this, but we're just relaxing our stipulation for what a black pixel is. But however, we will be changing the black pixels to pure blue. And then our yellow pixels here, let's go ahead and say our red has to be greater than 200, our green has to be greater than 200, and our blue has to be less than, let's say, 50. Okay? And so if we were to run this again, and if we look, right, notice all of those black pixels that weren't changed to blue have now been changed to blue. And if we look at our middle section though, right, there's still this outline of yellow. If I can click on one of them, let's see, right, oh, that's not one. That's not one either. I'll keep on clicking on the white. Oh gosh, I'm really good at this. Oh, perfect, perfect. There's one. Right, notice in this case here, that's one of the yellow pixels. We had to be greater than 200, greater than 200, less than 50. In that case there, the blue is 72, which does not account for that. So if we were to make this even more relaxed, like if we had to say this is just less than, let's say 100, if we run that, it should be a little bit better. Yeah, it's a little bit better there. I don't know if you can see it on the video, but there still is there's faint yellow. There's faint yellow, right? If we want it to be perfect, we could go in and so notice here, like that last one there, it's a high level of blue as well. So we could relax this threshold even more to try to encompass every single or every single close to yellow pixel. But for the sake of this video, I'm gonna just stop. But you can keep relaxing your mask in order to fully encompass everything. And so that's pretty cool, right? So we were able to change an image, right? We were able to change colors and create a new image here. So we changed the Belgian flag to the French flag. So a common type of image manipulation that we like to do with colors is the concept of green screening, right? So green screening, like if you've seen on movies, it's the process by which an actor or like a model or something will pose or act in front of like a obnoxious green screen, and then in editing they go back and they can change that green to something else, some other sort of background. So we're going to do that same exact thing but in MATLAB. So I have two pictures here, right? So I have our original Serena picture that we've been dealing with. So if I were to do, let's say I am read serena.jpg, right? So we have this picture here. However, I went into Paint and I did some beautiful green screening where I went ahead and changed the background of Serena to this obnoxious green, right? So it's not perfect. It's not close to perfect, but it's good enough, right? And so so what we want to do here is we want to replace that background, that green screen, with someone who is far inferior to Serena, and that is Maria Sharapova. If you don't know, she is probably like the most trash tennis player ever, but I don't like her. And she's on this magazine cover, and I think that Serena should be on there. So let's go ahead and put Serena over this magazine cover so that she covers up Maria. Petty, definitely, but that's what we're going to do. And so in order for this to happen, so the first thing here, right, so I have these two images. Well, let me minimize this a little bit here. And, oh gosh, technology. And let me resize that a little bit there. So I have these two images, right? And if I'm going to be putting this one inside of this green space here, they're going to have to be the same size, right? And so in order to do that, the first thing I have to do is I have to make sure that this picture of Maria Sharapova is also the same size as the picture of Serena. So let's do that. So let's go ahead and figure out what is our size of the Serena picture. So I have that as Serena, size of Serena Green. Okay, and so here, this is the size of the Serena picture, and I want to make the Maria Sharapova picture the same exact size. So therefore, we're going to overwrite this background, and we're going to say I am resize of background. That's the Maria picture. And the new number of rows that I want will be the same exact number of rows as my Serena picture, and the new number of columns, the same exact columns. So here, now my new background will have the same number of rows, same number of columns as the Serena picture. So the next thing we need to do is we need to find the green pixels in the Serena picture. And so we have to create a mask in order to do that. So first, let's separate our image into 3 different layers. Right? So Serena Green first layer, G Serena Green second layer, and B Serena Green third layer. Third layer. Okay. And so now we have to create this green, or this mask, for our green pixels. So let's call it green mask. And so our pure green is where our red is equal to 0, and our green is equal to 255, and our blue is equal to 0. Okay, and so now essentially what I want to do here is I want to transfer, so let's go back to this, every single pixel on this background at every single layer to those same exact, or where this green part is, I want to transfer them over, right? And so that process there, that operation is the same for the red, green, and blue. And so this is a good time to use like a 3-dimensional mask or super mask here. In the previous example, I was changing separate layers to different colors, so I couldn't use a super mask for this. But in this case here, I'm just moving over a whole bunch of pixels. So the same operation is being done on each layer, and that's when I can use a super mask. So let's go ahead and create a 3-dimensional version of this mask. So we'll call it super green mask. And that'll be cat, the 3rd dimension, and I want green mask, green mask, green mask. All right, awesome. So then now, like I said before, I need to move the pixels from the background image where the original Serena, or not the original, the green Serena picture is green. So in this case here, wherever these green pixels are, those same places in this background image, I want to take those pixels and move them over. And so if we think about that, on the right-hand side of the assignment operator, I want to go into my background picture where the green pixels are in the other picture, so super green mask. And I want to take them and I want to put them inside of this Serena green at the location of the green pixels, so super green mask. And it's as simple as that, right? So if I were to figure, and then I am show Serena green. Let's close all CLC. So let's run this. I think everything's suppressed, right? So we have this. Oh, this is what it's supposed to be, right? Notice it does not look like anything happened, right? And so if we look at this green here, lo and behold, it is not pure green. Notice the blue is 1, right? So therefore, like we did in our other example, we're going to have to put some sort of threshold onto our mask. So let's go ahead and say a green pixel is when the red is less than 50, the green is greater than 200, and the blue is less than 50. And so if I were to run this again, Boom, right? So we now have this beautiful picture of Serena overshadowing Maria Sharapova. And you can see like the edges, we can still see the green, and that's because those did not fall into our threshold. If I wanted to make a perfect picture, I could just keep on relaxing that threshold that we have for our mask until we get it to work. But wow, this is a beautiful picture, I would say. And we did it all with just some simple code in MATLAB. No Photoshop necessary. Not saying that you shouldn't use Photoshop for this. MATLAB's not made for this, but it's a cool application for indexing and logical indexing and arrays and things like that.